So good afternoon, everybody. Happy New Year 2026. I hope you have a nice Christmas holidays. And as I mentioned, welcome to this first new product release of this year at Epic. So the idea of these meetings is that our members can present new products, new solutions, new ideas to the market. So you can discuss with them about the specifications, characteristics, and potential applications if you are interested. So we have a nice set of presentations of new products, quite exciting new products that will be presented by some of our members today. And just a few words about Epic. As some of you already know, we are a consortium of 800 companies, more than 800 companies related with photonics technologies. And our task as Epic staff is to support any need they may have related with technological requests, access to markets or market reports, investment information, human resources support, and also networking like this activity and visibility where we give the opportunity to our members to present their solutions. So if you are interested in any of these topics, please feel free to contact me back or send me an email with the ideas that you may have, and we can help probably with some of them. And apart from this event, we are already informed about several of them, probably through our newsletter and also emailings, but just to encourage you again to go to our website to check what is happening. Of course, regarding the physical meetings, most of the activity in the next week will be related with Photonics West. So we will be in San Francisco, and we will do a lot of different events. So we have breakfast with the European projects and pilot lines, networking receptions, lunches, a lot of opportunities to network with all the Epic members and other companies. And then we will continue the rest of the year with our typical technological meetings and sessions in the events. So we will be present in February at Optro as well in Marseille. We will have a meeting on integrated photonics and packaging at FIX. And then we will talk about defense in a meeting hosted by our member Exosense in Toulouse. So we will be there in March. And again, online, we will continue with our set of online technology meetings, the work group for human resources, also sustainability. We will have a very interesting marketing meeting to understand what is happening of SEO versus AEO, and another technology report by the expert Hans Ditteltoll that we will do a summary of photonics in defense. That is a hot topic nowadays, as most of you are probably involved also in this topic. So as I mentioned, I'm not going to bother much with all this information, so I encourage you to go to our website and see which events are related with the topics or applications, markets that are interesting for your company. And let's go with our meeting today, because we have a quite packed agenda, and we can start with the first presentation. As you see, we have different topics, several of them related with lasers and laser sources, also QuantumDot color conversion, Simulot platform for PICs, fiber cables. So we cover very interesting different topics. And we will start with the presentation by the brand new member, FYLA. And we have today Beatriz Tuñón Grossi. She is the sales manager at Laser Business Unit, and she's going to present two new products, both Horizon and the Boreal. So Beatriz, the floor is yours, and you can share your screen now.
Thank you, Antonio. Okay. Well, good afternoon, everyone. Thank you very much, Antonio and Natasha, for giving us the opportunity to present our technology today. My name is Beatriz, and I'm the sales manager of our laser business unit here at FYLA. For those who don't know us, FYLA is a company that develops and manufactures ultra-fast fiber lasers. Particularly, we are experts in the development of supercontinuum sources. These kind of lasers, they have become essential tools in multiple applications, both in the academic and industrial fields. However, they present some limitations in terms of optical properties, which may prevent a broader adoption of these sources in the research field. So as a result, the idea is that today I introduce you some of the problems that we are addressing with our new designs of supercontinuum lasers to overcome these limits. Especially, I will present you our new Horizon supercontinuum laser. These are the main points of my presentation today. I will just give you a brief introduction of our company, mention the state of the art of the supercontinuum sources, so that I can introduce afterwards the Horizon supercontinuum laser, and finally conclude my presentation. So about FYLA, FYLA was founded in 2014. We are a medium-sized company. We are the only fiber laser manufacturer in Southern Europe. We are actually based in Valencia, Spain. And our main aim or vocation is to consolidate as a global reference in different sectors, such as, for example, scientific applications, manufacturing industry, and optical communications. As I mentioned before, our main core is the development of supercontinuum sources. So I just wanted to give you a brief explanation on what is a supercontinuum. A supercontinuum is a source of white light that is generated by the excitation of a nonlinear effects in an optical medium, and the most effective optical medium is a photonic crystal fiber. A photonic crystal fiber that can be excited with a single wavelength laser like this one, most commonly a pulse laser. So at the end, what you obtain is a source of white light. A source of white light that combines properties of a lamp, such as the broadband emission, and properties of a laser, such as the spatial coherence. So with this combination, supercontinuum sources offer unparalleled white light brightness, easy integration, low power consumption, and broadband tunability, especially if you combine the laser with specific filters. So how is supercontinuum generation produced? Well, the answer is in the special properties of the photonic crystal fibers, or PCFs. A PCF is a special type of fiber that has a transversal microstructure made up of silicon air holes. So basically the light is directed through the core of the fiber, and it is trapped by the high index contrast between the silica and the air holes. The interesting thing about this type of fibers compared to other kind of fibers is the fact that there is a lot of freedom for new designs of structures. Basically, you can have very small cores of high confinement, and you can get these different arbitrary dispersion properties. So at the end, what you can do is engineer the nonlinear effects happening inside of the fibers so that you can get the proper conditions for supercontinuum generation. And an example of the state-of-the-art supercontinuum source profile, spectral profile, would be shown here in this slide, where basically you can see a broadband spectral profile where the pulse to pulse coherence is, there is no temporal coherence between pulses, sorry. And the peak power of the pulses is limited by tens of paths. Also, you need to take into account that usually the state-of-the-art supercontinuum sources, they are not spectrally uniform, but they present a high intensity peak around the full width of maximum, in this case at 1064 nanometers of the laser. I also wanted to mention, identify several applications where supercontinuum sources have become essential. And this is due to the fact of the characteristics of these lasers, especially the ultra broadband spectrum and the narrow pulse duration, such as applications remaining related to fluorescence or confocal microscopy, where you can excite all the fluorophores with just one laser. There's also applications related to single molecule spectroscopy, single photon counting techniques, or even biomedical diffuse optics, where the ultra broadband spectrum of the laser is able to produce multispectral imaging. However, we have seen that there is a common limiting factor, which is the lack of the spectral flatness of the laser. So how are we addressing this at FYLA? Well, we propose new designs for supercontinuum generation in such a way that we are able to obtain an ultra-flat spectral profile. In this slide, in the left side, you can see the typical profile of the state-of-the-art of supercontinuum. What you can see here is an intensity peak near the full width of maximum, which occurs because of the pumping wavelength that is not efficiently generating supercontinuum. We have seen that this is related to the fact that the pulses that are able to excite the photonic crystal fibers, they are partially coherent. Whereas if we use a highly coherent pulse to generate the supercontinuum, you can obtain an ultra-flat supercontinuum like the one shown here, where there is a higher efficiency in the supercontinuum generation and better flatness in the spectral profile. It is below 10 dBs. We have also been able to obtain a higher spectral density in the visible range. Actually, this is the spectral profile of our horizon supercontinuum laser, which is our brand new alternative, the only ultra-flat supercontinuum laser in the market right now, with more than 4 watts of total power and more than 300 milliwatts in the visible range. With this, I just want to conclude, pointing out some of the main ideas that I showed you today. which are that supercontinuum lasers have become essential tools in numerous research fields, both biophotonics, materials research, or even astronomy. The state-of-the-art of supercontinuum lasers present moderate pulse peak powers and a spectral non-uniformity, and this limits, of course, their use in some of the research fields. And to overcome these limitations, we propose the horizon or horizon as a new supercontinuum design in order to have an ultra-flat spectrum. With this, I finish my presentation, and I remain at your disposal for any question that you may have. And of course, we would like to invite you to visit our booth at Photonics West next week, where you can see the equipment firsthand. Thank you very much.
Thank you very much, Beatriz. So as you mentioned, we have time for questions, so you can raise your hand and make the question directly to Beatriz. I have perhaps a first question is related with this highly coherent pulse. To generate this kind of pulse, do you need like a special kind of source? Do you need to change the pumping source? Was another kind of I don't know, trick with the
Yes, that's actually the main idea, yeah, to change the pumping source of the laser.
Okay.
Sí.
So it's a different pumping source. And which application do you see that could benefit more from this flat supercontinuum spectrum?
Well, we see lots of customers asking for a flatter spectral profile for optical characterization of photonic integrated circuits, for example. We have customers doing fluorescence, and they want to excite the samples with a similar or uniform spectral profile of the samples. And this would be some kind of examples for this.
Okay, that's interesting. Any other question in the room? Well, if not, we thank again, Beatriz. Thank you very much for your presentation today, and take note of the email. You can perhaps also put it in the chat, Beatriz, so anybody interested can contact you afterwards.
Thank you, Antonio.
Thank you for being here today. And we can move now to our next speaker. So we have now a presentation by Valdas Maslinskas. He's the product manager for high-intensity laser light conversion, and he's going to present the Pharos 5 millijoules femtosecond laser. So Valdas, the floor is yours.
So, hello, do you see my presentation?
Now it's working, yeah, and we hear you well.
Great, let's get a pointer. So hello, thank you, Antonio, for introduction. My name is Valdas Maslinskas. I'm a product manager at Light Conversion. I specialize in high-intensity systems, and today I'm gonna talk about the new iteration of our one of the most popular femtosecond laser, Pharos. So first of all, a little bit about light conversion. So we are a company more than 30 years old. Currently, we grew already to more than 700 of employees, and our current laser production is around 1,000 lasers per year. So we're based in Vilnius, in Lithuania, with many other photonics companies that you might know. Our main products that we produce are ytterbium-based femtosecond lasers. Also, those are complemented by wavelength tunable sources, mainly optical parametric amplifiers, spectroscopy systems, and also now recently we are venturing into microscopy sources, so for 2-photon and 3-photon microscopy, and also ultra high intensity OPCPA systems that can give you high peak and average power pulses. So why are ytterbium-based femtosecond lasers so popular nowadays? So one of the main reasons is, of course, that those lasers can give you high power and high repetition rate. So at Light Conversion, we are at 100-watt levels, but there's even possibility to go to the kilowatts, and also work at megahertz and more of a repetition rate. Also, another thing is the pulse-to-pulse stability or average power stability. So here in this histogram, you can see this is hundreds of our lasers put here with a relative standard deviation of a pulse-to-pulse energy represented, and this line here is our specification. So more than half of the lasers fall below 0.2% of a pulse-to-pulse stability. That is very good result. And another thing is that ytterbium lasers, they are as we like to call, industry grade. So we work for a very long time without touching anything. We have a number of lasers working 24/7 in the industrial facilities, and we even have some lasers working from 2009 non-stop up to today. So this really is a testament of how reliable those things are. So Pharos is one of our most popular lasers. It was the first ytterbium laser that we started producing. The main building blocks of it is well, similar to any other chirped pulse amplification systems. So we have an oscillator. We stretch oscillator pulse in the stretcher, amplify it in regenerative amplifier, and then compress it. So stretcher and compressor is one box. Also, we have high voltage supplies and Pockels cell drivers to run the Pockels cells in this system. And of course, this laser can be, we can add different add-ons. So in the most recent iteration, the Pharos could go up to 2 millijoules in pulse energy, 20 watts of average power, and had a lot of, different bells and whistles around it. We have more than 2,000 systems like that installed. And recently, we're happy that we finally managed to push the system to 5 millijoules of the pulse energy. So you can see how it fits into our energy versus rep rate graph of different lasers, different Pharos models that we produce. So basically, we're now starting to occupy this space from 2 millijoules to 5 millijoules. And the main application of such a laser would be as a driver for high harmonic generation, optical parametric chirp pulse amplification, systems pumping, terahertz generation, even electron acceleration, X-ray generation, and large area and volume material processing. Many of those applications cannot be done with a laser as it is, so we couple it with different options and add-ons. So for decreasing the pulse duration, we have a pulse compression setups that can shorten the 250 femtosecond pulse duration down to tens of a femtosecond seconds. We can also CEP lock the system. We can lock it to a synchrotron, to a free electron laser, or one laser to another. We can shift wavelengths with the help of an OPA. Also, if 5 millijoules is not enough, we can chain multiple lasers together. And just to illustrate the last 2 points, so for the laser to accept, to utilize the 5 millijoules pumping energy, we constructed a new optical parametric amplifier, or Orpheus HE. So this is specially designed to work with 5 millijoules from Pharos, and it can give tens and hundreds of microjoules of output power throughout tuning range from 200 nanometers down to 15 microns. And also, as we can now chain the multiple 5 millijoules lasers, here is one big system that we're installing this year. So this is an optical parametric chirp pulse amplification system at 2 microns, producing below 30 femtosecond pulses and 1.5 millijoules of energy at 4 kilohertz. And this is pumped with 4 nicely chained Pharos 5 millijoules. So this is all I wanted to say today. Thank you very much.
Thank you very much for the presentation today, Valdas. Again, we have time for questions. Is there any question in the room? I have perhaps one question related with this really long tunability that is quite impressive. So congratulations. In which applications do you see interest in going so far in the infrared? It's exploring particle physics and these kind of things, or
there are multiple, mostly I would say spectroscopic applications.
Okay.
If you think about going, to 10, 15 micrometers, there's this 2D IR spectroscopy and other things like that. So it's for exploring molecular vibrations. usually.
And when developing these kind of solutions, how difficult it is now to find optical components that can support this high energy and this kind of wavelengths, detectors, things like that? Because I guess you also need to work with your suppliers in developing specific components for the laser. So how difficult is for you? Do you need to really start in some cases from scratch with some companies, or do you have already identified companies that can support with this development?
It's I would say, yeah, twofold problem. One is the optics and the suppliers. Another one is just purely engineering. You know, how to make it work with maybe components that we had from the lasers with lower energy. But yeah, it was a challenge. So mostly on because, well, with higher energy, you have a higher beam, you need higher aperture, bigger aperture optics, and so on. And well, you need to keep them. It's uniform, nice, and so on. So it took some time, yes.
And regarding the user point of view, how difficult is now to play with these new lasers? Do they keep the same kind of friendly use of the lower power solutions, or are so special that they need some dedicated person to work with them?
No, it's well, the user friendliness is there. Of course, you know, with more energy, it's well, you need to be more careful, of course, with
Yeah.
all the reflections and everything that can go into the beam path. But from usability point of view, yeah, nothing changed.
Okay, very good. I don't know if there is any other question or comment. If not, you can, as I mentioned before, you can contact Valdas, and if you want to write also your email in the chat, they can contact you afterwards. So thank you, Valdas. Thank you very much for the presentation today. And we can move now to our next speaker. So we have Cara. So she's business developer at the company Liverage, and she's going to present the detecting defects in MPO array fiber cables or connectors. So Cara, the floor is yours. You can share your
Yes,
screen.
thank you, Antonio. Can you see my
Yeah,
presentation?
everything good.
Good. Good. So, hi, I'm Cara. I'm from Liverage Technology in Taiwan. So, yeah, let me tell you something about Liverage. So, we are founded in 2003 in Taiwan, Hsinchu, which is TSMC at. With over 30 years of experience, we are a leading manufacturer in the fiber optic component industry in Taiwan. And our core technology capabilities include optical packaging, customized manufacturing, and integrated testing systems. We employ advanced techniques like laser welding, epoxy packaging, and in-house module design. We also develop high-end fiber optic solutions for defense, aerospace, custom security, and oil exploration. We also have OEM and ODM solutions. And we maintain quality standards with ISO 9001, ISO 14001. We also have the TUV and CB certifications, underscoring our global commitment to safety, reliability, and environmental responsibility. We are also approved by the top tier companies and also received the Taiwanese government funding. We also partner with many universities and research institutes in Taiwan, and we accumulated 48 plus inventions, designs, and new patented technologies. So, give you some product overview. So, we specialize in the development and production of optical transceivers, such as SFP and QSFP modules, providing reliable solutions for 5G, data centers, and telecom infrastructures. And we also been dedicated to design and manufacture high quality optical testing solutions that help our partners to deliver faster and stronger, such as BER testers, MPO polarity testers, and other fiber optic diagnostics tools. So, yeah, we make advanced technology accessible, accurate, and dependable. So, as you know, the test equipment in fiber optics components is increasing and data center is demanding, expanding. So between 2025 and 2030, expected to be like 1,000 more of data centers. As networks continue to expand and scale complexity, the testing equipment is very critical. So we built a pocket-sized tool for on-site reality, the MPO Tester Mini. It is 124 times 108 times 45 nanometer. So it's like this big, as you can see. And it supports 12, 16, 24 channel fiber MPO configurations, 615 nanometer visible red light, optimized for clear visual identification of defects such as breaks, cracks, or bends in MPO fiber cables and connectors. So when it plugs in, it will show the light here. And the adjustable scanning time is 0.1 to 5 seconds for ultra-fast or high-precision testing, single mode and multi-mode compatibility, powered via USB standard C interface. And so how do we use it? Plug the MPO cable in. This is the button here. So plug it, and there are 4 modes. So you can switch it here. Sorry, I will have to show you like this. So you have to, when you press it, it will show differently. It is a scanning mode. This is the scanning mode. And then this is the switch mode. You can switch it here. So you can see it very fast. I hope you guys can see it though. And yeah, so most of the problem of the
Yes, we can, Cara.
yeah, no, sorry. So most of the problem can be solved here. This is the 4th mode, and we also have the GUI interface that you can switch it on the software, that you can change the channels, change the switching light, and everything here. And so the top market that we are heading for is the data center, cabling SI, MPO cable manufacturer, lab, brand, and the FTTH deployment. So it is very compatible and light, as you can see, and it minimizes the human error during the certification and lower all of the maintenance cost. And yes, thank you. This is my email and the sales mailbox.
Thank you very much, Cara. So again, we have time for questions, if any. I have a question regarding the use.
Yes.
For the connectors, do you need any adapter to connect the single mode or the multi-mode fibers, or is the
Yes,
same
yes, we
entrance?
do. Yes.
Okay, okay. And regarding the calibration of the tester, is some kind of procedure that you need to do from time to time, or do you send calibrated from factory and the user doesn't need to take care of it?
You mean the product? Do we have to
Yeah,
take care of?
calibration of the product for getting the same assurance, something to do from time to time, or any protocol?
Not really, not really. So we also have other type of the MPO tester, but it's a bigger one. And yeah, it's basically the same, but this one is like smaller and lighter. Yeah.
Okay, very good. And I don't know if you show something about the accuracy and repeatability of the measurement. I don't know if you show any data in your presentation, or if you can say a few
No,
words
I don't have
about.
any data sheet in this presentation, but in our website we do, and the data sheet can be downloaded.
Okay, okay,
Yes.
very good. I don't know if there is any other question. You can raise your hand. Well, if not, again, you have the Cara's email here, so please contact her for any further discussion. So, Cara, thank you very much for the presentation
Thank
today and for being
you.
here. And we can move now to our next presentation. So we have a presentation by the company Optiwave. So we have Sam Bonfil, the product manager of Optoelectronics, and we want to present OptiMega, the new simulation platform for peak design.
Hello, thanks
Hello,
Antonio
Sam.
for introduction. So I'll be talking about our new products. I'll start by introducing our company, do a little product overview, and then talk about Optiomega and how it can relate to our other products. So Optiwave started in Quebec, Canada, it's a spin-off from National Optics Institute. Over there, we've been in business for the past 30 years, and we have a very wide range of install base. Our product has been used by many corporations, defense contractors, and academics and research institutes. and it's been supporting many publications as well. We have a wide range of customers, as I mentioned, ranging from academia to corporations. So here are some of them. Now let's talk about the products. So we have 9 different products. What we do is mainly simulation software for optics and more specialized in photonics. On the left, we could see the system level software. We have OptiSystem that is used for optical transmission systems, LiDAR, quantum systems, UAVs, and much more. You can also use it for photonic integrated circuits. We have OptiSpice. It is more specialized for photonic integrated circuits where you can combine optics and electronics on the same platform, which is especially good when you're doing like control loops or you have any feedback in your system. We have component level simulators that solve Maxwell's equations in many different ways for device design. We have a general purpose FDTD product called OptiFDTD, and then we have waveguiding solvers, BPM. And also we have grating fiber mode. Optiomega is the latest one that we're going to talk about. It was just released end of last year. And OptiInstrument is another product where we use, now this is not a simulation software, it's a software we use for interfacing for controlling test equipment and interfacing with simulation products like OptiSystem. Now, Optiomega, it is a new platform where it is specialized for photonic integrated circuit device simulations and circuit simulations. We're going to be adding more and more solvers. Right now, there are only 2 solvers with this, but the idea is we're going to be expanding on it, and we're going to be adding more and more capabilities. Right now, we have a finite difference, fully vectorial finite difference mode solver we use together with an FDTD engine. This FDTD engine runs on the GPU, and everything is used with Python, so it's very easy to script, and you can take advantage of the Python libraries. It runs on locally, so you can run it on your computer if you have an appropriate GPU, or you can run it also on the cloud, so we don't have any restrictions on that. But we don't offer our own cloud services yet. It's something what we will look into down the road. So the GPU acceleration is a very important part of the product. Relative to our own FDTD, we see a lot of speed improvements when you move to GPU, and you'll see many other people using GPUs for accelerating simulations. It can get up to 100 times faster than running on the CPU. We have a CPML for absorbing boundary conditions. Now, as I mentioned, the workflow is specialized for photonic integrated circuits, so we're able to load in GDS masks very easily, as well as letting users define their own layer stack information with the thickness and the materials. We have port detection from the GDS so that user can just load their mask layout and don't have to worry about where to place the ports. And from the port detection, a lot of automation comes in place where we're able to figure out the size of the simulation domain. We're able to add extensions so that the input planes can be placed, the observers can be placed. We know how many simulations to run to generate the S parameters. So this is all automated. The idea is to reduce the amount of time for users to set up their simulations. We do subpixel averaging, and we support sidewall angles to capture, well, for subpixel averaging, it is to reduce the reflections due to staircasing or FDTD, and the sidewall angles is something that commonly happens during production. So we're able to support that with the GDS import. We automatically compute the S parameters because we detect ports, we know where they are and how many to run. We export the results as HDF5, so you can share them and use a lot of post-processing, different post-processing and scripting capabilities in Python or other languages. We have port reciprocity support. It means that you don't have to, if you have reciprocity in your design, you don't have to run all the ports. The auto shut off is also an important feature where we keep track of the amount of power that's in the simulation domain and shut off the simulation when it's done, and so that you run it optimally. And we also support optimization capabilities as well. Now let's look at take a quick look at how the port detection works. So this is I'm using Jupyter here for Python scripting. We use the GDS factory, but you can use also Lucida or any other tool that can generate the GDS. And all we need to do is load the GDS. do a bit of scripting. There's only 3 places where you need to make a change when you go from one design to the other. We're changing the name, obviously. Now we're going from a coupler to a crossing. And then the direction of the ports, instead of X, they're both in X and Y direction. And now we're able to detect the ports again. So let me move on to the next one. There you go. Now here I'm showing how we're able to do a length sweep for a coupler. So we're defining the materials, we're defining the layer stack, the background and substrate material. We have a loop that sets up the coupling coefficients, and we generate a new coupler every time. And at the bottom, you see there are maybe 5 or 6 lines of code that sets up your simulation. We hit run, we collect the results, and then we're able to plot the S parameters very quickly. So this shows the change in S31 as a function of coupler length. Okay, now finally so when you generate the S parameter, you're able to use that with our own tools, with OptiSpice, for example, where you're able to build your schematic and then connect your devices together and then do your circuit level simulations. Also, we have connection with OptiSystem. There's a special case for OptiSystem where the Optiomega automatically adds the port locations in the S parameter file, and OptiSystem is able to read that. So when you load the S parameters, the ports are automatically placed in the right locations, and they follow where they are in the geometry. And you're able to do similar analysis, but now you have access to a much broader set of devices and analysis tools to further analyze your circuit design. OptiSystem also integrates with Lucida as well. So if you want to do your mask design, photonic integrated circuits, and then combine that with OptiSystem, you can do that. Thank you very much for listening. I'm open to any questions.
Thank you very much, Sim. So again, we have time for questions. I will start with a question regarding the platform. Is there any limit? Because we see people in PICs working with silicon, indium phosphate, different kind of platforms. Is there any limitation regarding the platform used by the final user of your tool?
No, currently we're able to support any platform as long as you're able to define the material. All the platforms are supported.
And the definition of the material is something that you also integrate in the software, or something that
yeah, the definition. So you can we have at the beginning of the script, you'll see, if you go back to the video, there's a place where you define the material refractive index and different ways of defining it. So we can also take in experimental data, or we can take in a file with refractive index measurements, and then that means you can pretty much support any platform.
And how do you use Optiwave nowadays? Capabilities of AI, machine learning is something that you also implement in your software, so the people can also, while they are developing, the system can learn and then support better.
So OptiSystem has some AI capabilities. I don't have all the details in mind for that. For Optiomega, we're also looking at machine learning for two aspects. One is device design, and the other is also the compact model generation, where you can use some machine learning algorithms when you're doing, for example, for some kind of interpolation between different sets of data or parametric fitting. So we're looking into AI for that. So we're going to be doing more and more. So this platform, we started by doing the simulation part. Now that we have the simulation part ready, we're going to be feeding the data that we generate into compact model builders. So that's kind of something that's coming up, and AI is going to be a part of that.
Okay, very good. I don't know if there is any other question. Well, if not, thank you very much again for the presentation, and thank you also for sharing all this information, and you can contact Sim for any further discussion later on. And we can move now to our next speaker. So we have Valeriia Grigel, technical sales engineer at the company QustomDot, and she's going to present the quantum dot color conversion. So the floor is yours, Valeriia.
Thank you, Antonio. Good evening, everyone. My name is Valeriia Grigel, and in the next 6 minutes, I will try to convince you and to show you how the QustomDot color conversion unlocks the performance and economics needed to make microLED commercially viable. But first thing first, QustomDot, who we are. QustomDot was created 6 years ago as a spin-off company from Ghent University. And over the course of these years, we've been able to raise 6 million euros to develop our commercially ready product. Also, we are focused on building a strong international team existing of the highly skilled experts. Our headquarters is in Belgium, and we also have additional local support when it comes to the Taiwan and China, with addition of the distributors agreement placed all across the world, which means when it comes to the supporting requests and needs for our customers, there is no matter where they are located around the globe, we're always there to support them. When it comes to our expertise as a company, QustomDot is working in intersection between quantum dots and quantum ink formulation. Our core expertise is about re-engineering the quantum dot surface chemistry to ensure that quantum dots are surviving the integration process and also performance requirements when it comes to the final device. And also, we always think together with our customers when it comes to solving their needs and challenges of quantum dot integration. We always work close with our customers, and by taking into account the feedback loop, we build our product. And our main product is a cadmium-free, quantum dot ink for next generation display technologies. Because let's be honest, we're all living in the world of displays, and we are dreaming about the AR glasses that working in high noon. We would like to see the car dashboards that having the seamless glass. But with the current existing technology of the LCD, LED and OLED, we know that they're hitting a wall when it comes to the brightness and energy efficiency requirements in these form factors. But then what's the answer? MicroLED is the answer. So already several industrial players and made big announcements. Also at many conferences, we saw exciting demos. But the main question is remaining. Will MicroLED be commercialized? And in order to commercialize MicroLED, the technology is still fighting the three-headed monster. It's cost, performance, and yield, especially when we're talking about the red efficiency and red performance. So I would say when we come to the understanding of the problem of the native RGB, so here we have on the top left the trend force report and overview that about 40% of the bill of material comes to the RGB MicroLED cost itself, and another 40% are related to the transfer and repair. So by adopting the quantum dot color conversion on your MicroLED technology, you can benefit on cost in several directions. So first one, definitely by decreasing, you can decrease by 20% your cost by replacing red native MicroLED with a red color conversion. And it brings you down to several more benefits. So for example, we all know that when it comes to the wafer, and we're talking about blue wafer only, there is quite some distribution of the wavelengths around the wafer, as shown on the very bottom image. And quantum dots can solve this issue. You don't need to repair, you don't need to discard any part of your wafer, so it's optimize your yield, simply by introducing quantum dot color conversion layer on top. Quantum dots, thanks to its intrinsic properties, can homogenize any variability along the wafer. So here we're talking about the repair and yield optimization, but also keep in mind that if you want to scale up production of the wafer, you don't need to worry about increase of inhomogeneity of the wavelengths across the bigger wafer, simply because QDCC can homogenize and fix this issue for you. And I would say that these benefits, they are not theoretical. The big players, starting from the Resolve and down to the Innolux, demonstrating the QDCC on the demos at the conferences, which means we have a strong point working forward in implementing QDCC for the next MicroLED displays. So we already established that market industry requires micro LED, and the efficiency of the current red light is not there, so it's a real bottleneck. So we were focusing on developing product, the color conversion red ink, that is suitable for the industrial scale application on a blue backplane, and it's suitable for the inkjet printing, which is not just lab scale solution, it's a proper industrial print deposition technique. Our QustomDot Gen 2 ink was tested by several top-tier display manufacturers, and they challenged us, and we delivered on several specs that were crucial for the industry. So first thing first, we are delivering at a scale, so we have pilot-ready product. The viscosity of our formulation was optimized to ensure the homogeneous jetting without clogging for sufficient duration at print temperature. Our product is a UV curable ink, and we deliver it at 2 different color points, it's 630 and 640 nanometers. The main focus for this product optimization was around photostability, so we're delivering about 200 hours T90, and also exceptional efficiency of about 40%. So our pilot-ready product is a solvent-free ink designed to survive the high blue light flux and still maintain efficiency over 40%. In case you're still not convinced, don't believe us, believe the industry. The big players like Innolux and from most recent AO during the IDW published a paper, and they confirming that the QDCC microtechnology exhibits the best overall performance. Thank you for your attention. If you are fighting the same issues and the same concerns when it comes to micro LED, please feel free to reach out, and let's connect during the SPA Photonics West next week in San Francisco. Thank you very much, Valeriia. So again, we have time for questions. And you mentioned in one of your slides that your core expertise is the ink, but then you also support the companies developing the devices. So what's normally your task in this way? How do you support the companies developing the device itself? So usually we meet at the sampling stage when potential partner comes to us for a solution. They have the first trial of our product, and then to iterate and to optimize our solution for their particular need, we usually have the collaboration iterations round. Mm-hmm. To be honest, I'm not an expert in this kind of topics and products, but what's the idea for the future is to develop like a set of different products, a kind of portfolio, or would you use the same ink, sorry, for different applications? So definitely, I would say the QustomDot ink is definitely a solid, good start to change the native micro LED, but definitely we are looking deeper into the more challenging fields of the AR, for example, where the specs are more demanding, and we are already trying to face and tackle these challenges. Okay, so perhaps you will need to develop new products once you understand which are the requirements. Definitely. Good, good. So I don't know if there is any other question for Valeriia. If not, you see in the screen her email, so please contact her for further discussion, and I hope we can meet in San Francisco, Valeriia, as well. Thank you, Antonio. Thank you very much. Thank you for being here today. And we can go now with our last presentation today. So we are back in Lithuania with Workshop of Photonics, and we have Ieva Neimantaite. Sorry for the surname. Key account manager at the Workshop of Photonics, and she's going to present the new Orizando, a new brand for advanced space variant retarders. So Ieva, the floor is yours.
Thank you very much.
Sorry that I probably said really bad your surname.
No, the pronunciation was fine. So thank you. Hello, everybody. My name is Ieva, and today I'm pleased to present the launch of our new brand, Orizando. So to start, let me give some context. Orizando is a new brand focused on space variant retarders. It was created by Workshop of Photonics, a company with more than 20 years of experience in femtosecond laser micromachining. And the Workshop of Photonics have introduced space variant retarders to the market back in 2012. And after more than a decade of success and global recognition in the optics and photonic industry, Workshop of Photonics established Orisando in 2025 as a distinct brand to strengthen its position in advanced polarization optics. Along with the brand launch, Orisando also has released an online eShop. The eShop allows customers to easily explore our standard products, purchase it, review the key specifications, and submit technical inquiries directly. With this background in mind, let's look at the technology. So our optics are fabricated using patented femtosecond direct laser writing technology. This process creates self-organizing nanograding inside of the bulk of fused silica. It is a periodic structure that has a bifringence. So this type of process allows nanometer level control of retardants and fast axis orientation. So each element can be designed with spatial varying bifringent properties across the multiple degrees of freedom and enables complex beam shaping and polarization conversions. So this approach allows us to combine very high precision with long-term stability, which is critical for demanding laser environments. So as a nanograding structure inside of the material, laser damage threshold is compatible to a standard fused silica, making our elements very suitable for high power systems. And based on this technology, let me explain how our optics works. So in standard waveplate, the fast axis orientation and retardants are constant across the whole aperture. And in space variant retarders, both perimeters can vary as a function of position. This allows spatial control of polarization, phase beam structure within a single flat optical element. This means that instead of using several optical elements, a single space variant retarder can perform multiple functions at once. And this brings us to our initial specs. So it's important to mention that all our elements are tailored according to customer requirements, and typically is fabricated into 1-inch substrate fused silica. However, we are not limited to that. We are open for the custom sizes. And the elements work for the specific wavelength. However, our customers can choose from UV, visible, and infrared spectral range. The retardance and aperture size is adjustable to customer requirements, and our elements show high transmission rates, especially in visible and infrared spectral range. Okay, yes. And Orisando offers different types of space variant retarders for various lasers application, and here you can see some of them listed. So S waveplate, higher order S waveplates, flat hexagons that convert Gaussian beam into Bessel-Gauss beam. This beam maintains its shape over a longer distance, and it's useful for laser processing like high aspect ratio drilling. And one element is able to produce negative, positive, negative, and combination of negative and positive Bessel-Gauss zones. Flat top converters that transform Gaussian beam into flat top beam, and it improves the quality and consistency in material processing. The polarization compensators, and I would like to highlight that Orisando also can provide custom solutions, so functions are very adaptable to the customer requirements. And I still have some time. I would like to highlight two of the elements. So one of the most selling one is our S waveplates. That is a standalone element that converts linear polarization to radial or azimuthal polarization. And with input beam being polarization, it can generate the optical vortex beam. Also, Orisando offers a developed and verified solution to solve the polarization issue, an optical element that compensates the distortion of original polarization in the gain medium. So due to unique properties of precisely inscribed nanograding, the polarization compensator is flexible, versatile, and it can be widely adjusted according to customer requirements. So in the summary, Autosanda combines the proven femtosecond laser fabrication technology with high design flexibility and strong performance for advanced polarization optics. So thank you very much. With that, I would like to thank you, and I'm here to answer your questions, and feel free to reach out to us. Thank you.
Thank you very much, Ieva. So again, time for questions. You mentioned that the size is customized, let's say, but it was the maximum size that you can offer to the customers, if there is any.
So the maximum clear aperture size is up to 20 millimeters. However, we are not limited to the substrate size, so it can be up to, I think, 200 millimeters if you want.
Okay.
But yeah.
And you mentioned the possibility of having or not having anti-reflective coatings, but what about filters? I don't know if it makes sense here to, if somebody asks for a filter, to have just this component for certain wavelength.
So we are not manufacturing the filters, but we are open all the time to discuss the customer needs and find solutions with our partners.
So there is the possibility of depositing some coating, extra coating with other third partner or whatever.
Yeah, we don't. Yes, we don't do the coating ourselves, but as we are from Lithuania, we have many good partners around us who do the coating.
Very good. What's the origin of this the product? Is something that you started implementing in the workshop of Photonics machines, or was an external idea that came to your portfolio?
So actually, it was developed with some Houghton University, and afterwards, yes, we also implemented it to our systems. But I think manufacturing of laser systems came before it.
Yeah. So we have Dimitri, question from Optoprim. You are muted now, Dimitri. Hello, Dimitri. Do you hear us?
Hello, can you hear me now?
Hello. Now we hear you, yes.
Yeah, I'm sorry for the technical difficulties.
No problem.
Optoprim Germany, Dimitri is my name. Yes, what about the damage threshold for these components?
So damage threshold is very high. It's the same as fused silica. So I think I had the numbers in my slides, but it's very high, as the structure is on the side of the bulk of fused silica. So it's same as the fused silica.
Very well, thank you.
And I guess this study of damage threshold is done with another company as well, with the Lidaris partners, perhaps there in Lithuania as well.
Yes, you can find all the measurements on our website. It was done by our partners.
Did you explore also other wavelengths in the visible range, or did you focus more in this infrared, near infrared wavelengths?
We have some limitations because of the fused silica, but that's why we are focusing on UV, visible, and infrared.
Okay, very good. So I don't see any other question. So Ieva, thank you very much for being here today.
Thank you. Big pleasure. Thank you.
Thank you also for sharing your contact details. So any other question, feel free to contact her. And you can see now in the screen the poll. So please, if you can take a couple of minutes to answer the questions there, it will help us to organize future events more efficient for you and more interesting for you. So we appreciate your answers. And thank you to everybody attending today, and thank you to all our speakers. So thank you, Beatriz, Valdas, Cara, Sam, Valeriia, and Ieva. Thank you very much for your time. And we will have this recording in YouTube, so feel free to come back to the recording, to any idea that you can in mind, and come back to me if you want to discuss with any of them or directly talk with any of the speakers. And I wish you a great afternoon, and I hope to see most of you in San Francisco next week. So thank you and good afternoon today. See you next time.
Thank you.
Thank you very much.
Thank you.
Cara.
Bye-bye.
Thank you.
Bye.